¿Qué onda? This is Mr. Pagana at the helm, and today we're talking about segment addition postulate. Now, the segment addition postulate basically says this. If you have one giant segment, let's call it AC. Okay, you have one giant segment, AC, and there's some point in between there. It could be anywhere. Let's just put point B here for the sake being. Alright, and what the segment addition postulate says, if I take AB, so the length of this piece, plus BC, the length of this piece, and add it all together, I get the length of AC, the entire thing. So for instance, if this is 6 and this is 12, AC would equal 18, 6 plus 12. Now, segment addition postulate is the fancy mathematical term for it, but an easy way to remember it is simply little piece plus little piece equals big piece. Alright, and that's kind of what helps me learn. Just little piece plus little piece equals big piece, and it's pretty self-explanatory. Take the two small pieces, add them together, you get the larger piece. Alright, segment addition postulate is the correct mathematical term. So, let's look at our first example. Now it says, M is between K and N. So, that tells me K and N are my endpoints. Okay, and M is somewhere in between. Now, we don't know where M is yet, so I'm just going to put it right here for now. Somewhere in between. It really doesn't matter to start, and we'll go back and analyze it later. So we know Km is 2x minus 4, Mn is 3x, and Kn, so the entire thing, is 26. Alright, so let's go through and do our math. We have little piece plus little piece equals the entire thing, the big piece. So this small segment plus this small segment equals the entire thing. The sum of the two little ones equal the big one. And then I combine my like terms, 2x and 3x give me 5x minus 4. And then go ahead and solve your equation. So I get 5x equals 30. Divide both sides by 5. And x is 6. So I've solved x. Typically it says solve for x, but also it might say find Km, find the measure of Mn. So you have to be careful when you're reading the problems, especially on your assessments. So let's take x and put it back in. So I have 3 times 6, which gives me 18. And over here I have 2 times 6 minus 4, which is 12 minus 4, which is 8. So to start, we actually put M here, but in reality, M should actually be further down the line here, right? If this piece is only 8 units and this piece is 18. So again, to start the problem, you really don't know. But once you have an understanding of what each segment equals, then you can go ahead and adjust as necessary. So I just wanted to point that out. Be ready to solve for any of the missing pieces of the diagram, and let's make sure that our point makes sense in between those two. It's not skewed in one direction or the other. Alright, so that's an easy example. You'll see a lot of those. Now for a little more challenging one. Alright, so I'm going to call this, let's call it Z. Let's put A like right here. We'll call that A, and we'll call this C. And I'm going to tell you ZA is x squared units. AC we're going to call negative x. And we're going to say the entire thing, ZC, is 20 units long. Aha! Okay, now, the variables aren't always going to be the little pieces. Sometimes the variable can show up in the whole segment too, but for this example it didn't. So we have little piece plus little piece, but in this case plus a negative x is the same as minus x equals the entire thing, which is 20. Alright, now whenever we have an x squared, this is a factoring problem, so we have to get it equal to 0 in order to solve. So I have x squared minus x minus 20 equals 0. Now that we're in our factoring form, we find two numbers, then multiply to negative 20 and add to negative 1. Alright, so that gives me x minus 5, x plus 4. Alright, so my two solutions are x equals 5 and x equals negative 4. Now, you have to be very, very, very careful when you're factoring to test both of your solutions. You have to make sure they work. Remember, we cannot have a negative length. That doesn't exist. You can't say something is negative 10 feet. Alright, so we have to make sure that our values give us positive and correct solutions. So let's try 5 first. Alright, so I'm going to go 5 squared, which is 25, and then we have negative x, so the opposite of 5, which gives me negative 5. So can AC be negative units long? No. That's impossible, so 5 actually doesn't work. Now let's test negative 4. So here I have negative 4 squared, which gives me 16. And I have the opposite of x, so I have the opposite of negative 4. The opposite of negative 4 is positive 4. 16 plus 4 equals 20. So that's my solution. Now again, you have to be very careful because sometimes both answers work, sometimes only one answers work, and sometimes none of them work. Now, you have a tendency to always cross out the negative answer because you're like, oh, it can't be negative. But no, it can't represent a negative within our line segment. Within our problem is the key, and that's what we need to test. Alright, so don't get fooled by that. Moving on. Now, this is your challenge problem for the night, and I want to talk about a few things. So it says, graph and label PB on the coordinate plane, line segment PB on the coordinate plane, provided point P and point B. Alright, so let's do that. Point P is negative 8, or all the way down here is point P. And B is 4, 8. So B is all the way up here. So your line segment is that piece there. Now, first it says find the slope. So remember, our slope is rise over run. Or you can use the formula. Now I'm going to let you go ahead and find that on your own. So you do rise over run, or you can use the formula. Okay, you learned that in our video the other night. Now part B says identify two possible points that would divide segment PB into lengths which are in a ratio of 1 to 3. Label them points A and J. Now, I'm not going to give you the solution to this because I want you to try it and think for yourself and bring that answer to class tomorrow. But I'm going to give you a small taste of what you need to do. So let's think of a line segment. Let's say I have a line segment. Whoa, that's not very straight. I have a line segment that is 9 units long. Okay, and let's say I want it in a ratio of 2 to 1. Okay, now, how could I chop the line of length 9 into a ratio of 2 to 1? Okay, well, let's first start by splitting into 3 equal parts. So I'm going to say this is 3, 3, 3. So if this is 9 feet long, I have 3 feet, 3 feet, 3 feet. So a ratio of 2 to 1 would be, if I put these two together, I get 6. And if I put this, I get 3. A ratio of 6 to 3 reduces to the same ratio as 2 to 1. Alright, so I want you to chew on that for a minute. Just think about that, and then go ahead and apply it to the problem above. See what you come up with, and be ready to discuss in class first thing tomorrow, and we'll go from there. Alright, thanks. I'm out.